laser pointer. My lecture today is called MediaPipe and Google Libraries, Down the Rabbit Hole. This is a short summary of my lecture. Forget what you thought you knew and fall down the rabbit hole. The lecture consists of three parts. First, what is MediaPipe for Dummies, then the bizarre Google world, and finally what MediaPipe really is. So part 1, what is MediaPipe for Dummies? Nowadays you can often hear things like, if you work in deep learning or perhaps computer vision, you must know Google MediaPipe. And MediaPipe is used internally in numerous Google products, including YouTube. So probably it's a good idea to know something about it. But most people who say you must know MediaPipe actually know nothing about MediaPipe. What people often think it is, in various forms, chats, and so on, that MediaPipe is a number of solutions, like hands detection, face landmarks, and so on, for Android, web, Python, and so on. People who think like that know nothing, absolutely nothing about MediaPipe, because all these solutions, it's not what MediaPipe is. The truth is, MediaPipe is a C++ multi-threaded framework for processing arbitrary data in a pipeline defined by a graph. And today I'm going to talk about both levels of reality, about what people think a little bit, and mostly about what MediaPipe really is. Here is a collection of useful links about MediaPipe, including the code, its open source, official site, list of publications, and so on and so forth. And also I wrote a little C++ tutorial myself while I studied MediaPipe. As you probably know, I spent some time studying MediaPipe this year, and it took a bit more time than I expected for the reasons which become clear later. And today I'm sharing with you this information. MediaPipe is officially in alpha version 1. It's not yet and probably never comes, might not be stable, still it's interesting enough. One thing I immediately note is that MediaPipe is poorly documented. This is not OpenCV with nice documentation. Here, to learn anything, you have to read examples and read the C++ source code and docstrings in the C++ code if you want to understand how to use various MediaPipe classes and functions. So I start with solutions. What are solutions? Solutions are ready-made pipelines for MediaPipe which are based on TensorFlow, actually TensorFlow to be precise. A typical solution is a MediaPipe graph with a pre-trained TensorFlow model and some visualization. And as an example, I'll show a video which maybe many of us seen.
The difficult problem. However, once it is solved, it unlocks various cases.
Did you see the people? Did you see the video with hands?
Yeah.
That's what MediaPipe hand tracking is. They have several solutions like that with hands, with face, and so on. And now back to our slides. Can you see the slides full screen again?
Yes.
Okay, so that's a typical MediaPipe solution, hence tracking. And there are a number of such solutions, and this table you can see for what platforms: Android, iOS, desktop C++, desktop Python, and JavaScript. In browser you have this solution. As you can see, not exactly cross-platform. Some of the cells are missing, although they're getting better. Used to be more empty cells, but slowly this table is get filled. Maybe nowadays it's larger, but when I wrote these slides, that maybe a couple of months ago, this table looked like that. Here you can see solutions for face, hands, paws, hair, object detection, and so on and so forth. That's what solutions are. They're not very interesting. Basically, just some kind of Lego brick you can put into your code. It's not very interesting. I said the real MediaPipe. I want the real MediaPipe. So I'm going from now on. I'm going to talk what MediaPipe really is, the lower level. And solutions, they are well documented. They are relatively easy to use, at least in Python. If you want to try, you can play around with solutions. Usually, that's where people start learning MediaPipe. I also started with solutions, using trying solutions in Python before moving to more interesting things. So, but what is mainly interesting for me in MediaPipe? That's pipelines and concept of pipeline and everything about pipeline. Maybe you know I many times publicly and privately discussed pipeline previously. What it's all about. And another reason to understand what is under the hood, so we can make something similar using media pipes like in their solutions, but maybe with different neural networks, with different visualizations, and so on. So pipelines, CVML projects typically require pipelines, and there are related concepts of data flow and flow-based programming with links on Wikipedia. If you onto Wikipedia, if you browse this presentation. What is pipeline? You have a number of nodes organized as a flow graph, which gives you modularity. And data packets run through the pipeline. Data packet can be one frame of a video or some chunk of audio or some other data. Nodes typically run, if it's possible, on many CPU threads in parallel, or perhaps in GPU sometimes. And buffers between nodes are usually required. For real-time pipelines, you absolutely need flow control, like packet loss on overflow. Otherwise, there is no real-time. It's very important. We discussed it many times, and I'll come back to this later today. On the other hand, for non-real-time pipelines, like you want to, for example, record one video from one codec to another codec, you typically want deterministic execution, no packet loss. There are two different situations. And the point is, designing a pipeline from the scratch is hard. Typically, in our IT gym project, when we wanted pipeline, we always try to design pipeline from the scratch. It's okay for POC level, but for at least big project and production levels, it's very difficult to design a pipeline from the scratch. It's generally much easier and safer and bug-free to use standard libraries for pipelines, such as GStreamer with DeepStream, MediaPipe, and ReftLib, and so on. And what was mostly interesting for me in MediaPipe, not neural networks, it's just TensorFlow under the hood. What's interesting about TensorFlow? What interested me in MediaPipe is a pipeline model. MediaPipe is a professional level pipeline framework from Google. And it was interesting for me, first, how professional level pipeline frameworks operate, and second, if this idea can be used in our project or perhaps MediaPipe directly. And next, if we talk about pipelines, maybe we all remember there is a thing called GStreamer, another pipeline frameworks. And there is MediaPipe, a new pipeline frameworks. Are they the same or similar or not very similar? What's the connection about GStreamer and MediaPipe? What's the difference? In this table, I'm trying to compare these two frameworks. And GStreamer is about 20 years old and part of GNOME universe. And MediaPipe is a recent framework from Google. GStreamer is really written in C with G-object, and MediaPipe is written on C++. Main purpose is somewhat different. GStreamer is mainly used for operations like audio-video conversion, filtering, resampling, and so on. While MediaPipe is mainly used for audio-video processing, usually with deep learning. GStreamer supports basically all audio-video codecs and formats you can think of. That's its thing. GStreamer supports all formats. It has many plugins with different for file formats and codecs, including most exotic ones. MediaPipe is not so interested in codecs and file formats. It can use some via OpenCV and FFmpeg, but it has no plugins of its own. The biggest and most significant difference is about buffering and flow control. GStreamer by default is extremely real-time. It has no buffering. If you have to enable buffers by hand, as far as I know, I don't remember GStreamer really well. While MediaPipe is the opposite. By default, it's deterministic, not losing any packets. There is unlimited buffering. You have to enable flow control by hand. What about using GPU and using neural networks? GStreamer can work with neural networks if you use NVIDIA DeepStream. NVIDIA DeepStream uses TensorRT for neural networks inference. Then, of course, it only works on NVIDIA GPUs, not anywhere else. While GStreamer without NVIDIA GPUs, I don't know if it can do anything with neural networks. Of course, you can write yourself, but it's not out of the box. While MediaPipe, you can use TensorFlow and TensorFlow Lite with or without the GPU, but no TensorRT. GStreamer is well documented, easy to use. There are tutorials, API reference, everything. MediaPipe is easy to use in your project. MediaPipe is hard to use if your project is poorly documented. That's difference definitely in favor of GStreamer. How you define a graph? In GStreamer, the simplest graphs can be defined by a text string, but anything more complicated, you have to code yourself in C or C++. It's not very nice. While MediaPipe uses Protobuf text string, which is easy and nice. More on it later. Question, do you hear me?
Yes.
Good. Let us continue. You think it's all very nice, but they say if it works in theory, it also works in practice, but only in theory. In practice, it's not work. So basically, MediaPipe is very good in theory, not so nice in practice. And with that thought, we come to the chapter 2 of my lecture, the bizarre Google world, Bazel, Protobuf, and so on. It's not that I wanted to learn everything about Google. No, basically I had no choice. If you want to understand MediaPipe, you really have to learn first some things from Google, or used by Google, which might seem very new and strange for you, including especially Bazel and Protobuf. Let's start with Google and C++. They say Google software does not work outside of Google. And after fooling around with MediaPipe, I can now confirm it's the truth. Let's compare how they use C++ normally and C++ Google way. Normally in C++ they use CMake or sometimes configure make, while for Google uses Bazel build system. What about dependencies, system libraries? Typically, only you install them with package manager such as apt on Linux or maybe VCPKG for Windows Visual Studio, while Google Way is building from the source. All your dependencies already strange. No using system libraries, already strange, isn't it? How do you find system libraries? You can use CMake or PKG config usually. Google Way, no system libraries. So if you really want to find system libraries with Bazel, it's not easy. You have to basically write some scripts by yourself. and IDE support. With normally CMake projects, almost any C++ IDE can be used, but for Bazel, none. At least for me, I couldn't find IDE which worked with Bazel. What on earth is Bazel? It's a multi-language build system which Google loves for some reason. And it can be used for different languages, but for C++ projects, the structure looks like that. You load C++ libraries, and you define CC, or that C++ binary, name of the executable, and source files. And the same way, you can define libraries, dependents, and so on. And that's the build file in every subdirectory, and workspace file is a project root, which can be empty or declare project dependencies. And then you type Bazel run fun1, that's directory hello, the target in fun1. And the same you can do with Bazel build. Bazel in practice. Bazel documentation says Bazel is the best, great, better than everybody else, blah, blah, blah. And also the idea of independence on Linux version, system libraries, and so on. Ubuntu version, not Ubuntu. What is Bazel in reality? When I tried experimenting with Bazel, first just for Hello World level project next to MediaPipe, I found out the following things. You can, with CMake or pkgconfig, you can easily find system libraries like OpenCV. And with Bazel, you cannot find system libraries, at least no easy way. I saw pkgconfig finder for Bazel from GitHub, but it did not work for me. By default, when you are building executable, it doesn't build ASO library dependence. Everything is compiled and goes straight into executable. This is very strange compared to CMake. Bazel style that you can have dependencies on other Bazel projects, and usually they are downloaded as sources from GitHub and built from the source. But dependency of dependency doesn't work properly. How stupid is that? There is MediaPipe repository, which is one huge Bazel project, but I couldn't use it as an external Bazel dependency because of some kind of dependency or dependency issues. And there is no IDE. In principle, there should be plugins for different IDEs, but I tried Bazel plugins for CLI, and it didn't work. It could only work with very old versions of CLI. I tried plugin for VS Code. For some reason, I couldn't understand. It didn't work either. Gave some strange errors. So basically, no Bazel plugins for IDE worked. I don't know what they used in Google, but I couldn't find solutions of IDEs that works with Bazel. Next. What is about MediaPipe? MediaPipe is already said is a huge Bazel project, and it has quite a number of dependencies. There are sources downloaded from GitHub when you build things, non-Google, several projects, including Ceres. And there are sources downloaded from GitHub, Google, which include Upsale, Google Test, Protobuf, and TensorFlow, and lots of Google libraries. And finally, there are choices between building from source or using system libraries, OpenCV and FFmpeg. I mean, MediaPipe really would love that you build everything from source, OpenCV and FFmpeg download, but it understands that some people cannot wait for a few hours while OpenCV, or at least, I don't know, half an hour maybe on modern computer, while OpenCV and FFmpeg builds. So it gives you the option to use system libraries, but it really doesn't like the idea. They would like that you downloaded everything from source, all dependencies. But here you can use system libraries if you really want to. So now the problem is using MediaPipe on desktop C++. How to use it in desktop C++ in your own project. And that's basically the worst thing about MediaPipe. we are used to the fact that usually your C++ project is CMake project. So if you so you can include every library in CMake project, like Boost or OpenCV or whatever, right? But here it doesn't work like that. You cannot do. There is no sudo apt install MediaPipe. There is simply no MediaPipe libraries you can include in your normal C++ project. So the only way you can use MediaPipe is to play by MediaPipe rules on MediaPipe territory, and that's really sucks. It's the worst thing about MediaPipe, which seriously makes it not so attractive. So how do you use MediaPipe? You download MediaPipe repository. There is no installation. It's a huge Bazel project. You can build and run examples. When you do Bazel build for the first time, it downloads and builds all kind of dependencies, including TensorFlow, which takes time. Downloaded from the internet and builds. And examples, they all sit inside MediaPipe source tree. And it builds your executables. No libraries are created in process. How do you create your project using MediaPipe? Basically, they have to be Bazel projects. And moreover, you have to put them into the MediaPipe source trees, like the examples, not independent external Bazel projects, but part of MediaPipe huge these Bazel projects. This is really ugly, and I really hate the idea. But all other options are impossible, or at least too complicated for beginners. The only way you can realistically try some hello world with MediaPipe is to work inside MediaPipe project, Bazel project, and that's what I did. What about other languages and platforms like Android, Python, and so on? It could be the standard solutions may be easy to install, but if you need custom calculators, water calculators I'll tell a bit later, you will have to build MediaPipe from source, which base will in C++, and moreover for all those platforms like Android. Not very nice. Next, I'll move to Google Protocol Buffers, or Protobuf. Why Protobuf? I had to learn it because it's used a lot in MediaPipe, and it's needed for MediaPipe. But while learning protocol buffers, I found out that it's kind of nice thing. And unlike MediaPipe, you can use it in CMake projects, and you can even use sudo apt install. Maybe not the latest version, but it works pretty nicely. So what's Protobuf? Protobuf is a framework for cross-language data description. You define a data structure in a proto file, which is some kind of data structure, like I don't know, user or bank or movie theater, so like some kind of data structure. And it's not in C++ or Python. Proto files are cross-language data description. Then you compile proto file into different languages, such as C++, Python, Java, and so on. They compile into classes of the respective languages. And of course, these are not pure classes of these languages. These are classes which require libprotobuf to use. And once you declare such classes, you can serialize and deserialize protobuf objects into binary format or optionally text format. And such serialization is cross-language and cross-platform. Once again, Protobuf can serialize only Protobuf classes, which can have fields of standard data types and other Protobuf classes only. You cannot serialize any other data. So please don't ask stupid questions if Protobuf can serialize OpenCV images or NumPy images or anything like this. Protobuf can serialize only Protobuf classes. And this is cross-platform, immune to 32-64-bit issues and little big endian issues and cross-language and so on. And you know, when I tried Protobuf, my personal impression, I really liked it. It's a rare thing that something from Google is really nice and really feels good to use. What can you use it for? You can use it for all kind of data serialization, config files. Basically, you often hear, even in our company, you sometimes hear words like JSON, XML, YAML, TOML, and so on. My personal opinion is like that. Try Protobuf. I would, every time somebody wants to use any of this format, I would replace it with Protobuf because it's more modern, easier to use, nicer. At least the alternative. At least give it a try. Especially if you want efficient binary serialization with Protobuf, it's much better than this format that took huge amount of space. And you can use it as for data serialization, also for config files. Like in many ITGM projects, we had some config in JSON and passing this JSON in C++, which was not very convenient. With Protobuf, you can do such things much easier. Protobuf is used heavily in Google projects, including TensorFlow, where binary PB files is, of course, Protobuf serialization of neural networks, containing all weights of neural networks and graphs. And MediaPipe uses text mode Protobuf format to not binary this time to define MediaPipe graphs. And as I said, unlike other Google libraries, it works with a sudo-apt install. You can use it in CMake projects in C++. You don't need Bazel. You don't need any of that stupid stuff. Maybe not the latest version, but it works. And please try it in real project. Nothing to do with MediaPipe. You can try it in real projects, even ITGM project in Python or in C++. If you never try, it's a nice thing to try. And all these things can be replaced by Protobuf. How does it look in practice? Let us define a data structure in Hero Pro. So that's language independent, message hero. Message is basically class. We define data structure hero, package which becomes C++ namespace. There are two language versions which are quite different, Proto 2 and Proto 3. You have to choose one of them. MediaPipe uses Proto 2, by the way. And the message hero includes name and a string name, integer age, quite a standard data structure. 1 and 2 are not defaults, as you might think from other languages, but field ID, which are required, unique IDs of every field in this data structure. Now let's compile into C++ code. You get two files, header and C++, which using Proto-C compiler. This code obviously requires libprotobuf to work. Wouldn't work by itself. And once we define the compiled into C++ class, you can define hero, and this it has getter, setter. You set the name and age of our hero. You can copy them, and copying Protobuf classes is cloning by value deep copy. And you can use getters, and you can have string representation, and you can serialize into binary. Here string is not used for any kind of text, but basically as a buffer for the string for the binary data. Serialize binary data, deserialize binary data. You can also serialize, deserialize into files, of course, and you can also use a text format module for text mode serialization, which looks like this: name and age. That's text mode serialization, which can replace things like JSON and XML and so on. And basically, that's all about Protobufs. Another Google library used by MediaPipe. I don't have time for everything, but Upsale is a basically Google answer to Boost. Lots of nice C++ goodies. MediaPipe uses it for status, that's error codes. It can also be used in CMake projects with sudo apt install. I would say it has nice things you can try it, but no time for details. Google Test is a popular unit test framework. GLog is more or less standard logger and probably the worst logger I have seen in my life for some technical reasons, which we don't have time now. At TensorFlow, I hope you all know what it is. There is a C++ version which also Bazel projects and has all kind of stupid ideas from Google. You cannot install with sudo apt install. You have to build from source TensorFlow C++, and it's not that easy to use in your projects. All these things are Bazel projects on GitHub, and sudo apt install versions either absent at all, or like for TensorFlow, or outdated like for Upsale. Now we are finished with part 2 of the lecture. Part 3. Do you hear me, people? Good, very good. Let us continue. We're almost there, but now it's part 3. I hope you are not sleeping yet. Just enjoy a little bit more. We're going to finish soon. Now, part 3. What MediaPipe really is. Now, finally, after all the introductory materials, we come to the real stuff. MediaPipe is a C++ framework for creating data pipelines. Basic terminology goes like this. Packet is an immutable data packet of an arbitrary type with a timestamp. MediaPipe also has standard types for image data and the audio data. Graph is a pipeline represented as a flow graph. Node is one node of the graph which processes data. Stream is the edge of the graph, a stream of packets with monotonously increasing timestamps, like frames from video or chunks of audio or something like that. And calculator is a registered class used for creating nodes. For example, calculator can scale image of each frame or do neural networks inference on each frame, some kind of image processing or audio processing or data processing operation. Calculator and node are like class and object, and you can have several nodes made of the same calculator. It's like a class for creating nodes. That's called calculator in MediaPipe. And once again, I did a lot of playing around with MediaPipe C++. I tried all these things in C++, and it was not very easy to learn because there is no proper documentation. You have to basically reverse engineer Google code and Google examples. And I wrote a tutorial which hopefully makes it easier to understand MediaPipe than just by reading the code and Google examples, which are not very nice. So please, if you are interested in MediaPipe, try my tutorial. It's here. And look into tutorial if you want the details. I'll give very simple introduction into MediaPipe C++ API. For example, graph can look like that, very simple graph. This is a text in Protobuf format. As I said, a text Protobuf format, which is like JSON, but a little bit different, as you can see. Input stream is in name of the input stream, where this is a entry point to the graph, and the output stream of the whole graph is out. And this is, by the way, visualization of graphs, which can be done on MediaPipe website. Try it out. And there are two nodes which uses the same calculator, pass-through calculator, which is kind of dummy calculator which does nothing with the packets. It just passes through the packets. What comes to the input of the calculator goes to the output of the calculator, and each calculator has its own input-output stream, which are different from input and output stream of the whole graph. And you can see, first calculator has in, and its output is called out1, that stream in the middle. And the second calculator from out1 makes out. That's what I meant by graph when I was using the word graph today. A graph of nodes connected with streams, and data flows through this graph like water through pipes or electricity through some electric circuit. I hope you understand this idea. It's not very complicated. And then what do we do in our C++ code? We take this string, text string with graph definition, and then we use parse text proto or die to deserialize the string and to calculate a graph config class. And then you define this graph with this config. And the nice macro np return if error basically means if there is OK status, continue execution. If it's error status, return error status. To use this, we need a function which returns MediaPipe status, which is actually Bazel status, which can be OK or different, if not OK, different error codes. And now we defined our graph from this text stream. What we do now? Remember, we have streams in and out. We have to do something about two streams. For input streams, we can submit data by hand. And for output streams, we have to put observer, a callback which is executed every time a new packet goes out of the graph, comes to stream out. So we defined an observer, a C++ lambda function, which receives packet and returns status. And this is the simplest observer, which just prints packet timestamp, and packet gets the value double, assuming that our data is double, as in my first few examples, and it return OK status. Then once we define this observer, we have to attach this observer to stream out, and then we start running the graph. When we call graph start run, MediaPipe starts running the graph, and when it receives the data gets immediately processed by MediaPipe engine, which internally uses different threads on this graph, and processed data starts to, and when the data is processed, it will start to call this callback, the observer. Note that packet is a data class for MediaPipe packets. To those who know some C++, it's like an immutable version of GStreamer of any. Like any, it's a template which can hold different data types. Internally, it's pointer to unknown data type. And as GStreamer, it can be copied by reference counting. But unlike GStreamer of any, packet is also immutable by definition. And next, in my first example, we have to send the packet to the input stream. So MediaPipe is already up and running. It's processing our packet. By packets, it's ready to receive data, but there is no data yet. So let's send it some data. In this loop, we send 13 packets with increasing timestamp, and you create packet with make packet of type double, some value, and don't forget to add timestamp. Then you run add packet to input stream. So all this packet, like every packet goes to input stream, and the MediaPipe processes all your packets and calls our callback. That's basically how it works. And in the end, you have to put close input stream so that MediaPipe knows that no more packets are coming. And after we do close input string, we can do on the graph wait until done. And because it knows that input stream is closed, no more packet incoming. It will wait until all packets are processed and then finishes the program. Congratulations, that's the simplest MediaPipe usage example in C++. And next, let's write a custom calculator. Calculator must be defined in MediaPipe namespace and other ugly things. They must be registered so the MediaPipe can find them with name by some funny macros. And they inherit calculator base, and they at minimum should define two abstract methods. Get contract specifies our contract. Contract is basically what inputs our calculator has and what outputs. Here we set one input of type double, one output of type double, and return OK. And next process method is called for each packets this arrive, or if you have several inputs for each timestamp. Packets are automatically synchronized by timestamp by MediaPipe. And here you get one input, packet P in. From it we can get X double. Using get double, multiply X by 2. And remember, packets are immutable. You cannot modify packets. You have to create, if you multiply by double by 2, you have to create a new packet. You create a new packet from Y, add the same timestamp of input packets, and then send this packet to output stream out. That's typically what process does. That's the simplest example, and in my tutorial you can find more interesting examples of custom calculators. But of course, if you want to know MediaPipe really and use MediaPipe really, it's not enough to use standard calculators. You have to be able to write your custom calculators, including ones for image and video information. And how do you configure your calculator? There are several choices. Options are configured. Options are given at the time the graph is defined. When you define each node in a graph, you specify calculator name, input and output streams. You can also add options. Like this is standard image cropping calculator from MediaPipe. You can specify width or height for cropping. You can also use input side packets, which are submitted not at each, you have no timestamp, and they're submitted once when you start running the graph, and they're available in all calculators for use. And if you need something depending on time, you can create an extra stream with some options and parameters, for example, for each frame with video, and they should be timestamp synchronized with your video. And my tutorial has examples of how to use these things, options and side packets, and your own calculators. So look at the tutorial. We don't have time now. And now let's look at the solutions. Here it's a face detection solutions from MediaPipe. Let's look at the graph. There is input video, that's the input stream, FlowLimiter. On next slide I'll tell what it is. Then this face detection from CPU, that's actually a subgraph. It's another graph used as a calculator. Then you have another subgraph, detection to render data. We somehow, or maybe it's calculator, I don't remember, we somehow modified the data, and annotation overlay, which visualizes this detection on the image. And the interesting calculator face detection from CPU, it has converts the image to tensor, and then it has inference. Inference is a calculator which does the actual inference with TensorFlow Lite. It's just a wrapper around TensorFlow Lite. And then some more transformations like tensor to detection, non-maximum suppression, and so on. Just look at the code if you want the details. What is FlowLimiter? As I remember, I told you about real-time pipelines, which must be kept real-time. If something is too slow, you should lose the data. And non-real-time pipeline where every packet must be processed. By default, MediaPipe is deterministic, meaning it's not real-time. Packets are queued, also buffered in each stream. Unlimited. The queue is unlimited. Every packet is processed. No packet is lost. And the buffer size is again unlimited. We can smell trouble coming, folks. Suppose now that our pipeline is real-time. Input comes from a camera or TV stream. In camera that doesn't wait for you to process your packets. What if your calculator, for example, in neural net, is not fast enough? Then these buffers, they grow indefinitely, and the lag, the delay of the output streams grows all the time. First, the lag is maybe seconds, then lag 10 seconds and 20 seconds, and finally the computer runs out of RAM and program crashes. I have seen such things many times in real life. Basically, all kind happens all the time. If inexperienced people try to design real-time pipelines, they can easily do things like that. They forget to lose packets, and you get pipeline which doesn't work, where lag grows indefinitely until the program crashes. I have seen such things several times in real life, including in our company. Very common situation. That's why when you design real-time pipeline, you have to always remember that you have to limit the buffer size. You have to lose packets if your neural network or some kind of algorithm is too slow. I discussed it many times. I hope you understand. It's very important. But what about MediaPipe? MediaPipe by default is deterministic, not real time. Can we make it real time? Yes. There are different. You have to limit buffer sizes and lose packet on buffer overflow. How to make MediaPipe deterministic? There are several solutions, but most common, and it's used in the Google examples and solutions, is the FlowLimiter calculator. What does it do? FlowLimiter calculator receives your input data, for example, video, but it can be any kind of data, and then it also receives output video looped back like that as a second input of FlowLimiter after the end of your entire pipeline. How does it work? It compares your timestamp of the input stream of output stream. If your process neural networks is too slow, then here it's a bottleneck, a choke point. You can have a long queue of packets queuing here, like a traffic jam, I don't know, on Ukrainian Polish board. A long queue which gets larger and larger every second. That's our problem we want to avoid. But if you have a long queue here, then our timestamp or output video will be very different from input video, maybe 10 frames and 100 frames and 1000 frames. And what does FlowLimiter do? It compares timestamp of input and output stream, and if the timestamp are too different, it means that our queue are too large, and then the FlowLimiter start actually to lose input packets to relieve the whole pipeline. And this is one of the simple and efficient ways to deal with the real-time issue. And you can configure FlowLimiter how much exactly the difference between input-output timestamps you are allowing. And that's the way you can make MediaPipe real-time used in Google examples and solutions. So MediaPipe has a number of standard calculators for a lot of them. I didn't try them all. Different sections like audio, core, image, tensor, TensorFlow, TF-Lite, util, and video. Most interesting are image, video, and perhaps neural network inference. But I didn't try them all. By the time I was learning, Bazel, Protobuf, all the stuff we discussed today, you're bored of my lecture. And I also got bored after studying this stuff for a couple of months and decided to make a break. Okay, if I ever need MediaPipe again, I can easily come back. For now, let's make a break. It's enough to know that there are calculators for neural network inference and for some image processing. And remember, if you want some kind of custom algorithm, most likely MediaPipe doesn't have a calculator for exactly what you want. Most likely you will have to write your own calculator in C++. And now we're almost finished. Summary. Protobuf is a very nice library which can use also in CMake projects and in Python projects. I would very much recommend to try it instead of all this JSON, XML, YAML, TOML, and so on. MediaPipe C++ requires Bazel. Nice, but only if you can stand Bazel. I hate Bazel, and I found that you cannot use it in normal C++ project, or is a very big minus of MediaPipe. What about MediaPipe for other languages and platforms? Basically, it's a wrapper in Python and Android and so on against a standard C++ MediaPipe, which requires Bazel to build. Solutions are very easy. You just, I don't know, import the Python libraries and use solutions. But unfortunately, remember, solutions are just standard things. What if you want something custom? If you want graphs made of standard calculators, probably you can also use standard Python library. But real MediaPipe is about writing custom calculators, and they can be only done in C++. And if you want, for example, in Python project to use custom calculators, remember that your calculators can be only written in C++, not in Python, not in Kotlin, not in Java, only Swift, only C++. And second, if you want custom calculators, you have to rebuild C++ code of MediaPipe, which means for Python you have to rebuild all Python MediaPipe wrapper from the scratch from in C++, and of course you need Bazel for that. So MediaPipe in Python, Android, and so on, it's very easy if you want standard solution, not so easy if you want custom calculators, because then you have to write stuff in C++ and rebuild from the sources. I'm finished. Thank you for your attention.